Sanbonani Dumelang. My name is Dumsane. Are you ready for more exponents? Have you seen exponents written like this? 3 to the power minus 5. What do you think this means? How about this one? 3 to the power of 0. What do you think that means? Today we are going to look at negative and zero exponents. So, by the end of this lesson, you should be able to convert powers with a negative exponent to powers with a positive exponent. Explain the meaning of a power with a zero as an exponent. Do you still remember the law of division of powers? When we divide powers of the same base, let's say we have 3 to the power 7 divided by 3 to the power of 2. We subtract the exponents. So in this case, we'll have 3 to the power 7 minus 2, which will give us 3 to the power 5. But what if we have a number like this? 3 to the power 2 divided by 3 to the power 7. The number in the denominator is a higher power of 3 than the number in the numerator. The law for division of powers with the same base still applies. So, now we have 3 to the power 2, take away 7, which will give us 3 to the power negative 5. But we prefer to write powers with positive exponents only. This makes it easier to solve exponential calculations. So how can we write 3 to negative 5 with a positive exponent? When we are working out how rules work, it is always useful to start by expanding the example. So in this case, we'll have 3 times 3 divided by 3 times 3 times 3 times 3 times 3 times 3 times 3 7 times. So we can cancel out at the top. 3 into 3, it's 1. 3 into 3 is also 1. So what do we have? 1 times 1 gives us 1 over, how many 3's do we have at the bottom? 1, 2, 3, 4, 5. Therefore, it will be 3 to the power of 5. The first answer we got was 3 to the negative 5. The second answer we got was 1 divided by 3 to the power of 5. Both must be correct. So, we can say that they are equal. It's time for a definition. Any number to a negative power will be the same as 1 divided by that number to a positive power. Let's take an example. 8 to the power minus 5 will be the same as 1 divided by 8 to the power of positive 5. Right, let's move on to some calculations with negative exponents. Is there a difference between 2 to the negative 1 multiplied by 3 to the negative 1 and 2 to the negative 1 plus 3 to the negative 1? Right, here we're multiplying powers with negative exponents, whereas here we're adding powers with negative exponents. Remember what we just learned? Now, 2 to the power minus 1 can be written as 1 over 2 to the positive 1, which is the same as 1 over 2, multiplied by 3 to the power minus 1 which can also be written as 1 over 3 to the power positive 1, which is the same as 1 over 3. We are multiplying, therefore we can multiply the numerator with the numerator, which gives us 1. Then we multiply the denominator with the denominator, 2 times 3, which will give us 6. Whereas with your addition, we'll have 2 to the power minus 1, which can be written as 1 over 2 to the positive 1, which is the same as 1 over 2, plus 3 to the power minus 1 can also be written as 1 over 3 to the positive 1, which is the same as 1 over 3. In this case, we're not multiplying, we are adding. Therefore, we look for a lowest common denominator between 2 and 3. The lowest common denominator here will be the number 6. 2 goes how many times into 6? It goes 3 times. 3 times 1 will give us 3, plus 3 into 6 goes twice, then 2 times 1, that will give us 2. Add the 2, 3 plus 2 gives us 5 over the denominator of 6. Clearly, multiplying 2 powers gives us a very different answer from adding 2 powers. Can you help me with this one? You can write this as a to the power minus 2 multiplied by b to the power minus 3, which is the same as 1 over a to the power 2 multiplied by 1 over b to the power 3. And now you can multiply the two factors, which will give you 1 over a to the power 2, b to the power 3. Remember that the bases are different, so we can't add the exponents. But this one is a little different. A to the power minus 2 plus b to the power minus 3. Do you recognize that there are 2 terms here? To simplify this, we treat each term separately. So in this case, we'll have 1 over a to the power 2 plus 1 over b to the power 3. We need to find a lowest common denominator between the two. So what do we need here? We need to have a b to the power 3. So we multiply the bottom here by b to the power 3. The golden rule in mathematics, whatever you do at the bottom, you should also do at the top. So that means here, we'll multiply the top as well by b to the power 3. We do the same thing on the right hand side. We need an a squared. That means we multiply the bottom there by a squared. Golden rule, we do it as well at the top. So to be a to the power 2. Now what do we have? We have b to the power 3 over a squared b to the power 3 plus a squared over b. Okay, we can write it as a to the power 2 b to the power 3. Denominators are the same, so that means we can simply add the numerators. That means our answer will be b to the power 3 plus a squared divided by a to the power 2 b to the power 3. How about this one? Simplify. 3 divided by 3 to the power minus 1. Do you have any idea what to do? Let us read it again. 3 divided by 3 to the power minus 1. How about writing it this way? 3 to the power 1 divided by 3 to the power minus 1. Remember our second law says if we're dividing powers with the same base, that means we can simply subtract the exponents. That will be the same as 3 to the power 1, negative and a negative gives us a positive 1. So that will be the same as 3 to the power of 2, which is the same as 9. Well, I'm sure that you have a pretty good understanding of negative exponents. But what if the exponent is 0? What do you think is 3 to the power of 0? Is it 3? Is it 0? Or is it 1? I'll show you how to solve this mystery. Right, first tell me what is 3 divided by 3? Yes, it is equals to 1. Remember, 3 is the same as 3 to the power 1, and that means that is the same as 3 to the power of 1. Let's apply our laws. Law of division. When we're dividing, we said we can subtract our exponents. Therefore, that will be the same as 3 to the power 1, take away 1, which gives us 3 to the power of 0. Now, let's look at this. 1 is the same as 3 to the power 0. That means we can conclude and say 1 will be equals to 3 to the power of 0. And what about 0 to the power of 0? Well, 0 to the power of 0 will be the same as 0 to the power 1 divided by 0 to the power 1. But 0 divided by 0 is meaningless. Therefore, we can say that 0 to the power of 0 is meaningless. We now know any number to the power of 0 is 1. So m to the power of 0 is 1. And ABC, all to the power of 0, will be equals to 1. Let's look again at what we did today. We found that a number raised to a negative exponent is the same as 1 divided by that number to a positive exponent. We also proved that a to the power of 0 is equals to 1, except in the case where a is equals to 0, because 0 to the power of 0 is meaningless. Are you ready to check whether you are on track with exponents? Can you convert numbers with negative exponents to numbers with positive exponents? Can you use 1 equals to a to the power of 0? Here's a task for you. Write this expression with positive exponents. 2 to the power of 0 times 2 to the power minus 3 times 3 to the power minus 1, all divided by 2 to the minus 5 times 3 to the power minus 4. Then prove that that will be equals to 2 to the power of 2 times 3 to the power of 3. Well, folks, that was all for today. Can you see how easy it is to work with negative exponents? You can do it. Go and practice working with exponents. Until next time we see you. Goodbye.